There are four key concepts to follow for this problem. First one is to write out the governing equation, and the second step is to integrate the governing equation over the control volume, and the third step is to relate the integrated equation with different nodes, and the fourth one is to rearrange the equation to a nice looking form. So let's first take a look at the governing equation. So in this case, we're going to use our heat diffusion equation in two-dimensional without heat generation. Also, it is going to be steady state as well. So we're going to integrate this equation once. So now let's take a look at the governing equation. So we're going to use the heat diffusion equation in 2D without heat generation and also assuming the process is in steady state. And now we can integrate this equation over the control volume. So normally we will write out dV to represent the control volume, but here we're only writing out dx and dy because, like we said, it's a 2D problem. So the dz term automatically goes to 1. So now if we integrate this equation once, this is what we get. Because for the first term, we're only integrating over dx, so the dy got carried over. Similarly, for the second term, since we're integrating over dy first, so the dx got carried over. So now we can integrate this equation one more time, and this is what we get. Please be very careful. The first term is in the x direction, so we're evaluating from the west face to the east face. And for the second term, it's in the y direction, so we're evaluating from the south face to the north face. So this allows us to further expand this equation in this form. So basically, we have the east face minus the west face in the x direction, and then we have the north face minus the south face in the y direction. And we're going to use this equation throughout our analysis. So now let's first take a look at the interior nodes, which are highlighted in black. We also have our control volume, so I'm just picking a random control volume. So the equation that we're going to derive is going to